I have a question here to solve, but before then, let us have a recap of certain key points. We have here a straight line having two coordinates A and B on it. First key point, find the length or the distance between the 2 points A and B. This is given by the formula square root of change in s2 minus s1 squared plus y2 minus y1 squared. This formula gives you the distance between the 2 points A and B. Second point, find the gradient of line AB. The gradient of line AB is given by the formula change in y2 minus y1 divided by change in s2 minus s1. Or you can use the formula gradient of line AB because tan theta, where theta is the acute angle made by the straight line with the horizontal. That's what I've indicated there. Theta is the angle made by the horizontal. Is the angle made by the straight line. Now, and next key point, find the gradient of line PQ. Let line PQ be one that makes 90 degrees or makes 90 degrees with line AB. So I draw a line making 90 degrees with line AB. Okay. So we have P here, Q here. I have drawn line PQ which makes 90 degrees with line AB. So the gradient of line PQ is going to be -1 divided by gradient of line AB. When the two lines meet at 90 degrees, this will be the relation between the two gradients. Next key point, in the course of our solving, we'll come across an expression of this, an equation of this kind called the quadratic equation. How do you solve for S? Note that A, B, and C are certain values, they are constant, and you want to solve for S. We use the formula minus B plus or minus square root of B squared, square root of B squared C, all divide 2A. So we substitute the values of A, B, and C into this formula to solve for S. We will also come across an expression of this nature, A minus B squared. How is it expressed? We write A and square it plus take the other value in the bracket minus B squared. Next, multiply the exponent 2 by A and then minus B. Write it this way, A minus B squared is giving us A squared. Next, multiply 2. Next, write plus multiply 2 by each of the terms in the bracket. right, plus. Next, you are going to write the second term minus b squared. So an example, you want to expand 3s minus 5. What's the answer? If you do this well, 3s all squared gives you 9s squared. Multiply 2 by 3s and by minus 5, you are going to get minus 30s. Now, square minus 5. So this is the answer to the question. Now let's go ahead and solve the question here. Solutions to this question by accurate drawing will not be accepted. The points A and B are vertices of an isosceles triangle ABC, where the angle at B is 90 degrees. Find the length of the line AB. For this question, okay, let's make a sketch of the triangle. We are told we have a certain triangle. And the angle at B is 90 degrees. Coordinate of the point A is minus 3, 2. Coordinate of the point B, 1, 4. The coordinate of C is not given. Let it be S, Y. Now, first question, we have to find the length of line segment AB. Finding the length of a line segment from line the square root of, we are dealing with A and B, so when you go to the coordinate B, the S value there is 2. Go to the coordinate A, the S value there is minus 3. So S2 minus S1 squared plus y2 minus y1 squared, and that gives square root of, we have here in the first bracket 4 squared 16. We have in the second bracket 2 squared gives you 4. So the length of line segment AB, square root of 20 units, and this same as 4.47 units. Next, we are asked to find the equation of the line AB. Finding the equation of line AB, we need the gradient of line AB. So gradient of line AB equals change in y, y2 minus y1 divide s2 minus s1, and that gives 1 out of 2. So the equation, we have to find the equation of the line BC. Okay, finding the equation of line BC, the gradient of BC is not known. So what we can do is first of all find the gradient of line segment AB, which we have done. We now use this gradient to find the gradient of BC. So gradient of BC equals minus 1 divided by gradient of AB. Because these two lines AB and AC meet at 90 degrees, so we can make use of this relation to solve a gradient of BC. So we get minus 2. Now go ahead and find the equation of line BC. Equation of straight line y minus y1. Now the line B is on line BC that we are finding, so we can substitute the coordinate B into the general equation from y minus y1 because A multiply S minus S1. So now our y1 is 4 equals gradient of BC is minus 2 multiply S minus S1 is 1. So we get y minus 4 equals minus 2s plus 2, adding Adding 4 to both sides, you get y equals minus 2s plus 6 as the equation of line BC. Next, we are to find the coordinates of each of the two positions, of each of the two possible positions of C. Okay. Finding the coordinates of C, we see that line AB and line AC intersect at C. So what may come to mind is to solve these two lines AC and BC simultaneously to get the coordinate C. We know the equation of line BC alright, but the equation of line AC is not known, and it's difficult to get the equation of AC because the gradient of AC is not known. So let's think of some other way to solve. The equation says that the points A and B are vertices of an isosceles triangle, which says that the isosceles triangle, that's to say two sides of the triangle are of same length. The line AC is the hypotenuse, is the longest side of the triangle, and its length cannot be equal to any of the other two sides. That's to say that the two sides of this 90-degree triangle that are equal are lines AB and BC at the two equal lengths. So let's make use of this information to solve. The length of BC was the length of AB. That's what the equation says, that the triangle is isosceles. Now, length of BC, S2. Now, S2 is the coordinate S in the point C. S2, S minus S1. So S minus 1 squared plus Y2 minus Y1 squared. And also for the right hand side, length of AB is root 20. Now take the square of both sides and expand the left hand side. What do you get? You get S squared minus 2S plus 1 plus Y squared minus 8Y plus 16 plus 20. And this gives S squared minus 2S plus Y squared minus 8Y. Now 1 plus 16, that's 17. 17 minus 20 gives you minus 3 or 0. Let this be a second equation. And the equation of BC, let it be a first equation. We want to solve for the coordinate of C, the value of S and the value of Y. So solving the equation 1 and equation 2 simultaneously will give us those values. So the value for Y, we substitute minus 2S plus 6. So I write S squared minus 2S plus minus 2S plus 6 squared minus 8 multiply minus 2S plus 6 minus 3 equals 0. Expanding this further, S squared minus 2S plus 4S squared minus 24S plus 36 minus 8 multiplied minus 2S gives you plus 16S minus 8 multiplied 6 gives you minus 48 plus 3 equals 0. Simplify further. S squared plus 4s squared gives you 5s squared minus 2s minus 24s, that's minus 26s, minus 26 plus 16 gives you minus 10s. Now we are left 36 minus 48, that gives you minus 12. Minus 12 minus 3 gives you minus 15, because we can reduce this further by dividing each term by 5. That gives s squared minus 2s minus 3 equals 0. Now use the quadratic formula to solve this equation. S equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So we get two values for s. For the first value of s, we use the plus sign. Second value for s, we use the minus sign. We get these two answers. S1 is minus 1. S2 is 3. Now, we have found the two possible values for s. We are left with the y coordinate. So how do we solve? Substitute the s values found into equation 1. Substitute the s values into equation 1. So this is what we want to do now. Y1 is going to be minus 2s. Now the value of s1 is minus 1. Y1 equals minus 2s plus 6. And this gives it y2. For y2, we substitute s2 into the equation 1. And we have it this way. 0. So it tells us that the coordinate of C is either S1, Y1, or coordinate of C S2, Y2. Find the coordinates of each of the two possible positions of C. So these are the answers.